One of the most important aspects of working with assemblies is defining the correct motion between components. Fusion 360 makes it simple to define motion by using joints, which snap points together on two components and then open up certain degrees of freedom to achieve the right motion. There are 7 joint options to choose from, each one having different motion associated with mechanical connections. The first joint type is the rigid joint, which locks all degrees of freedom and keeps the two components fixed to one another. You can see this animation when I click the play button. The two components shake on screen to show that they're fixed to one another. The alignment options above set the relative position of the joint origins and are available for all joint types. The second joint type is the revolute joint, which has a single rotational degree of freedom, much like a hinge. When I select this option, an additional motion option, rotate, becomes available. This specifies the axis that the components will rotate about. As I change this option, notice that the preview of the motion changes. If I don't want the rotation around the standard X, Y, and Z axes, I can select an edge in the model to use as a custom axis to rotate about. The next joint type is the slider joint. As the name implies, this joint type is used for components to slide along one another, having a single translational degree of freedom. The options for the slider joint are similar to the revolute joint, except the axis that's selected allows the components to slide in that direction instead of rotating around the axis. The cylindrical joint type is the first joint to open up 2 degrees of freedom. Components joined with a cylindrical joint can translate and rotate around the same axis. Since the same axis is used for translation and rotation, only one axis option can be selected. If I animate the preview, you can see that the first selected component spins around the axis as it translates back and forth. The pin slot joint type also allows for 2 degrees of freedom, one translational and one rotational, but in this case, the axes can be different from one another. Because of this difference, 2 motion options are available, one to control the rotation and another for the translation, or slide. If I click the Animate button, notice that the first selected component translates, or slides, in one direction while rotating around a different axis. The planar joint type allows for the most degrees of freedom, 3. The planar joint allows for 2 directions of translation within a plane and a single rotational direction normal to that plane. It is designed for joining 2 components such that they can slide fully across them and rotate across that planar surface. A simple way of thinking about this is a hockey puck sliding across the ice. The puck can move in 2 directions on the ice, and it can rotate as it slides. To make working with planar joints easier, I recommend specifying the rotation axis first, and the sliding directions will automatically be set to the other 2 axes. The final type of joint type is the ball joint. This joint has 2 degrees of rotational freedom, pitch and yaw. These 2 terms may be a little unfamiliar, but all that you need to know here is that the pitch allows the components to rotate around the z-axis, while the yaw rotates the components around the x-axis. Choosing the right joint type is fairly intuitive, and it's always best to choose a joint type that only opens up the necessary degrees of freedom. This will keep the model from moving unexpectedly. Not only will this make the model more robust, but it will also reduce the computations needed when experimenting with the assembly, which will help speed up the design process.